This video, let's talk about the property called commutative property. In this case, we need to first understand what exactly is commutative, then we'll fill up this table. Now, what is commutative? Now, if I take two numbers, let's say 2 plus 3, the answer is 5. Can I write them the other way around? That is 3 plus 2. The answer is again 5. Okay, this kind of property is called as commutative property. Now, would that be always true and for all the operations? Now, this is what we got to check. Anyway, let's take this. I can write 2 plus 3 as 3 plus 2, and both of them would give the same answer, 5 and 5. So if this is satisfying, then I say commutative law is satisfied, commutative property is satisfied. So I generally like A plus B. If it is equal to B plus A, that's the commutative property. Now let's check whether it is possible into subtraction. Let's take 2 minus 3, which is minus 1, and what is 3 minus 2? That is plus 1. Now I can see that these guys are not equal. So here, commutative property would not hold good, and that's what the whole argument is all about. Now if I take 2 divided by 3, will that be equal to 3 divided by 2? No, it will not be equal to. So similarly, I can say 2 minus 3 would not be equal to 3 minus 2. Here the answer would be minus 1, here the answer is plus 1. They are not equal, right? So I can see that commutative property is one in which if I take two numbers and add them in this way, I get the same answer in both the cases if I reverse it and add, right? That is commutative property. It does not satisfy in subtraction and multiplication both. Now let's talk about whole numbers and the operations of addition. Right, let me take two whole numbers. Let's say whole numbers of this side. Okay, let me write that for you. 0, 1, 2, 3, 4, 5. It goes like that till the end. I'm taking any two whole numbers and checking whether it satisfies commutative law or not. Let's say I take 3 plus 4. Okay, these two guys. The answer is what? 4 plus 3. Both the times I'm getting 7. It's equal to 7. So yes, I can see that the property satisfies. And can you think of two numbers, any two numbers, and add them in this fashion and the other way around, you will in fact get the same answer. So I can say for all A and B which belong to whole numbers, A plus B would be equal to B plus A. And I say yes. The remark is commutative law, commutative property is satisfied. Alright? So I can write this. Very simple. Okay, now let's go with the next one. So let's close this guy. I'm talking about subtraction. Now I'm taking two numbers which are whole numbers again, and I'm trying to subtract them and see into this fashion. All right. Let's take these two numbers which both belong to the whole numbers. Let's talk about 5. It belongs to whole numbers, and let's say 6 or let's say 7 belongs to whole numbers. Both of them do belong to whole numbers. I'm now checking whether subtraction is commutative on whole numbers or not. Okay, fine. So let's take this. Let me take 5 minus 7, that is minus 2, and 7 minus 5 is plus 2. I can see that these two are not same. So I can say 5 minus 7 is not equal to 7 minus 5. So I can see this guy is 2 and this guy is minus 2. They're not same at all. So I can definitely say that subtraction is not commutative on whole numbers. I can say that subtraction is not commutative on whole numbers. If you want to write an example, you can just write 5 and 7 which belong to whole numbers, and 5 minus 7 is not equal to 7 minus 5. Okay, that's all about it. We fill this way. Now, what next? Let's talk about another thing about multiplication. Do you think multiplication would be commutative on whole numbers? Let's take two numbers. Let's take 7 and 3. What is 7 into 3? That is 21, and 21 belongs to whole numbers, and 3 into 7 is again 21. So I can see that 7 into 3 or 3 into 7, it gives me the same answer. So I can say yes, multiplication is commutative on whole numbers. So very simple. I can say that any A and B which belongs to whole numbers, A into B would be equal to B into A. Right? That's commutative. So I can write the remark. So I can say for all A and B which belong to whole numbers, I can see that A into B is equal to B into A. Right? So I talk about multiplication. Yes, I can say yes. Multiplication is commutative on whole numbers. Now we answer that. Now what's the last thing? It's all about division. Let's check it out here. Take two numbers, let's say A is equal to 5 and B is equal to 8. Okay, now divide them. So I have A by B, that is 5 by 8. Is that equal to 8 by 5? No, it's not. I'm just reversing it. Can I say A divided by B is equal to B divided by A? Or I can say 5 divided by 8 is equal to 8 divided by 5? No, it's not. Because this is 5 by 8 and this is 8 by 5, which are two different numbers. So I can say again back here that when I talk about division, for all A and B which belong to W, A divided by B would not be equal to B divided by A, right? So I can say division is not commutative on whole numbers. And it's all about a simple argument what we had done, and we can actually, with a little common sense, if you know what are numbers and what exactly is commutative law and property, you can fill this up very easily, right? So let's go with the next video and see how it works.